Welcome to Analyst Crossfire, an ISC'14 wrap-up show featuring expert voices from the international supercomputing community, giving their reactions to some of the top HPC trends as discussed at this year's conference. I'm Addison Snell with Intersect 360 Research, and I'm your moderator for this panel. And joining me as usual, I've selected 2 members of the HPC technology vendor community and 2 from the HPC user community. These 4 have volunteered to play the analyst by sharing their personal opinions on current and future supercomputing trends. Representing the vendor community, I've tapped 2 companies each in a state of transition. Brian Connors is the Vice President of R&D for the System X division at IBM, soon headed to Lenovo. Brian, welcome to Crossfire. And a return panelist to the Crossfire format, the HPC International Business Director for Bull, soon to be part of Atos, Jean-Marc Denis. Thank you for joining us, Jean-Marc. From the HPC user community, we have 2 highly esteemed representatives of prestigious HPC sites, starting with a key member of our HPC 500 user group, the HPC technical lead for Rolls-Royce, Yoon Ho. Yoon, thanks for lending your voice to the panel. And finally, another return panelist and a very popular one. Our audience will be thrilled to welcome back the director of HLRS, Michael Resch. Welcome back, Michael. Panelists, thank you all for joining me for an ISC Analyst Crossfire. The clock is running. Let's get started. Issue number 1 is cloud computing. Clearly, there's been some growth in the use of public cloud in HPC. We're tracking that in our forecast. Long term, how much in-house hardware spending can practically be replaced by cloud? And how much additional spending comes into HPC because of cloud? Jean-Marc, you guys have a cloud practice. I'm going to start with you.
Yes, we do. At Bull, we have developed a cloud offer specialized for HPC. This is Bull Extreme Factory offer. So through that offer, we have observed there is indeed 2 kinds of clouds. There are private clouds and public clouds. And what we observe is that for private clouds, that is in use in large corporations,
really talking about public cloud here, though.
So I'm going to come
right,
to
we'll
that very quickly.
Fast panel.
So private clouds are for big corporations. It's about consolidation at the software level of the many resources available through the corporations. Public cloud is much more for SME, for small academic users. And on that aspect, this is new usage of cloud and new usage of HPC. So that it replaces purchase of small resources or departmental resources, I don't think so. This is additional for absorbing some big research.
Your argument is that public cloud is for a small company that wouldn't otherwise buy it, but they use it in the cloud instead.
This is the point, yes.
Ryan,
this
what do
is
you
a
think?
complete observation.
But among existing HPC users, you don't see them spending less and moving some to the cloud. Okay, go Brian.
Yeah, so no 2 clouds look alike. We look in the sky, there's no cloud that looks the same for sure. So I somewhat agree. I think clearly as users out there, people, HPC users, they need more and more cores. This is bare metal, and more is important. It's not like a virtualized environment where we're sharing and utilizing infrastructure. So first and foremost, I think it's not going to replace purchases. Number 2, it's going to accelerate purchases because it's going to reach a missing middle. It's going to reach the ability to have access to people who may not be able to afford large clusters and capability to do applications and high-performance computing as a result.
You're both going the same way here. You're saying an existing HPC user doesn't spend any less internally and doesn't really go to cloud. The public cloud usage is a small company that wouldn't buy otherwise.
I think where it's coming into where it's really useful for a company who has an existing system internally is to burst. Clearly to burst and to be able to get access to the capacity that they need externally. So
you guys are telling me that all of the cloud usage in Amazon and everywhere else so far is net new revenue to HPC that wouldn't have been captured otherwise?
No new HPC revenue for hardware.
Yeah, okay. All right, so Michael's champing at the bit down there. We are seeing higher adoption of cloud in public sector versus private sector. I'm going to start with Michael. What do you think on this topic?
HPC is sort of the pathfinding technology that we have. So the higher end of HPC is the top of the pyramid, the top 500 or maybe even only the top 200 or so. They are more or less influenced by anything that compares
So
to
you don't
the cloud.
consider an SME to be part of the HPC market to begin with, is what you're saying?
Yes, yes.
You got to expand your mind here a little bit for this
At the
question.
bottom of the pyramid, at the bottom of the pyramid of HPC, there is a huge base. And this huge base is going to replace their own systems by cloud services. And at the same time, because cloud services are available, we increase the number of people that make use of the cloud base.
Now this is different, because you said it is for small companies, but you said it's going to replace in-house hardware spending. That's going to go
Definitely.
away, and then cloud comes in.
Definitely.
You're right in the middle of this with manufacturing. What are you seeing with cloud, public cloud?
So, speaking from the engineering manufacturing perspective, we have a lot of constraints in our simulation. Security is one of them, export control, our workloads are very heavy, and the bandwidth of the internet is not going to satisfy the large file transfer. So the answer to the first part of your question is, I'm with these two guys, I can't see us stop buying our HPC system and use cloud services. Certainly not within the foreseeable futures. That having said, there are cases where we will go out to use some kind of cloud services. These are external computing centers that have been cleared by our security people. So some kind of cloud. But these are well-defined set of applications and use cases. For example, R&T, where we don't expose too much of the IPR, and we don't expose or contravene any of the export control regulations.
All right, so let me double click on that and drill down a little bit on this. If you're an established HPC user, like Rolls-Royce or somebody else, is cloud in of itself inherently a desirable goal? I mean, what's the point of trying to do it? You set cloud as a goal and say we have to go do this? Why?
I think it has a lot of advantages for capacity bursting, for example. You can only buy that many in-house systems. There's
Okay.
always a budget. You have to operate within what is given to you.
Michael, you're smirking again. Is cloud a desirable goal in of itself? You know what I really need to do
Yes,
is
it
cloud? It is.
The reason I'm smiling is that we are very much provider-driven, very much driven by what do we think, how we can use our resources or make best use of the resources. The cloud, from the point of view of the user, the real end user, of my user in a sense, is just a better way of making use of a resource that is expensive and difficult to handle and everything. So inside larger companies, the cloud, the benefit of the cloud is probably better usage. But
You guys are
much more
nodding
important
here.
is
I agree.
that the end users, the engineers, they will be much more happy with an environment that makes it much easier to use this
Is there a
technology.
limit to this? Are we just going to move everything to cloud because that's what we want to do? No, go ahead, Brian.
No, absolutely not. I think, again, I come back to users want to handle their own data, the security of their own data. They want to have the capability to access their systems when they need to use them. We at IBM, we do have a software product for HPC. We just started that up. I think there's a reverse is occurring. The reverse is occurring. You asked two questions. One is it being replaced? I don't think so. Two is it can be more spent. There is more spend.
Intersect 360 is seeing a lot of the elbow in this where the spending's starting to come up is going to start being replacement. In our end user research, just last year for the first time, we're starting to get HPC sites who are telling us, starting going forward, we're going to spend 20% less and move the balance to the cloud. Topic moved on. Issue number 2, manufacturing scalability. Many engineering applications, it's been our observation in the manufacturing segment, like structural analysis as an example, have not seen the same real advancements in scalability that we've seen in other areas. What needs to be done to better address the needs of this segment? And you, and I'm going to you first because this is you right here.
Thank you. So certainly from Rolls-Royce perspective, our key HPC usage is on computational fluid dynamics, CFD. On CFD front, we have been able to scale our application.
CFD, I think, is scaling better than structures.
Yeah, it does. But up to several thousand cores, where if you look at the roadmap where you want to go, you want to take simulation to, even CFD is beginning to hit a scalability wall.
If structures scaled better, would you do more of it?
Structure at the moment is almost on the par with our CFD code.
Okay.
We use
Is this an area that needs more work, and if so, what?
I think, okay, so let me just separate the two. So for in-house CF code, because we've been able to scale the code out of several thousand cores to go to the next level of scalability, what we desperately need are skills. Very good computer scientists.
From where?
Software, exactly. From the universities, from working with vendors, with even groups of supercomputing centers. So
Michael, he needs better skills coming from universities. What do you think on this topic? What do we need to do to scale these better?
I want to provide him with that. I think people have to do their homework. And I, like 5 years ago, I said there is a gap between what we're doing at the high end of HPC and what real people are doing in the real world. When I say people have to do their homework, it's first of all the hardware vendors. We would like to see systems that are usable. What we get is systems that are big and fast and everything, but structural mechanics is just one example where an application is left behind that requires a huge amount of CPU time, but just cannot get it because the systems don't provide it. Second,
You want,
structural
you want a
mechanics.
differentiated hardware architecture that'll help with this?
I would like to see a reasonable hardware architecture.
Aha, Brian, what do you think?
I think, well, I'd be happy to build you one. But I think access to the hardware, again, to the mid-market, to the community, to people and subject matter experts that can get access to it is first and foremost. I think second is simple and easy to use. I agree. The ability to build out solutions, to be able to test and configure.
You're the wrong guy. IBM is actually building the systems that come closest to what I think is interesting.
Thank you. So I think again, the system plus the tools plus the collaboration with the ISV and our ability to deploy and help manage these environments that are simple for users to get access to, I think is very important. So we have application-ready environments that are fully tested and configured for things like ANSYS and others that want to do CFD in other areas for the mid-market. Access is important, this is where the cloud can come into play to help the community. I think the third piece is...
Hang on, Michael. Jean-Marc, you've been patient. Does Bull want to play in this conversation?
I would like to restart from the beginning of the discussion to some extent because we have moved to the hardware question, why this is not a hardware question. This is all about commercial applications. Manufacturing applications are driven by commercial applications. By definition...
That's true. This segment has the highest proportion of ISV purchase license applications.
Let me
Keep going, keep going, Jean-Marc.
Homework is ISV, homework is mathematical models. It's not that it's to blame the hardware. We have to blame the people who don't do
You want to blame the ISVs?
We have to blame the ISVs and we have to blame the hardware. And this is a disaster because all three of them just failed on this topic.
Keep going, Jean-Marc.
ISVs are very conservative. Their job is to make money through the development of
Now, wait a
applications.
minute. They're very conservative. Their job is to make money. We're going to criticize them for that?
No, because
Are they should they be charities?
No. But they are conservative to some extent. And the fact is that the free lunch is over. In the past, we had new performance through improvement in hardware.
The problem is they're too conservative. They ought to make a big investment without understanding how much someone's going to pay for it.
Now,
Is anyone right now complaining that they don't pay enough for software? Especially in this segment? You see the hard thing here. You're telling the ISVs to make a bigger commitment while you're telling them they want to pay less.
sorry, I would like to go to the end of my point.
Okay.
That's very important. I think that for moving to the next step of scalability, ISVs have to redesign their application, and this is driven by the evolution of hardware architecture. And the point is that today nobody knows what hardware architecture will drive the future. So ISVs are just waiting
That's
for
a
a
good
winner.
point.
They are waiting for a winner. As long as the winner is not there, is it in the SIMD direction, so GPU-like? Is it something else? They will not move.
That's a very good point. You know, we went through this in the Beowulf revolution to clusters. It took a while before all these codes had effective, scalable MPI implementations. And now that we're looking at multi-core, at accelerators, at ARM, floating point DSPs, FPGAs, what's the ISV supposed to double down on? Clock moved on. Issue number 3 is the ultra-scale enigma. This is having a big market effect for us now that we're seeing as analysts. A lot of the technology investment right now is getting driven by ultra-scale, or you could call it hyperscale internet infrastructures like Google, Facebook, Yahoo. Do you consider what they're doing to be supercomputing? And should all of us be watching them for trends or technologies to adopt through HPC? Michael, I really want you first on this because I know you've got an opinion here.
I don't have an opinion about Google and Facebook and everything.
Well, is it supercomputing?
We always have this subject. The supercomputing for me is when you put a single system to a single problem and most people miss that and come up with a solution. I don't see that Google or Facebook or anyone is providing us with a solution for a single problem on a single system.
So anything they're investing in is not going to help you?
I haven't seen anything so far. My kids like it, but I haven't seen anything that helps me so far.
Brian?
There's a big area we play in because we play
I
very closely with all these folks in Web 2.0. First of all, at this point today, I do not see them being supercomputers. I do see them in the future. I see with all the mobile devices on all the sensors out there, I see a lot of high performance analytics to occur in the future and the capability that they're going to build out. I think the opposite is true. If you look at Web 2.0, you look at the Facebook, you look at the Google data centers, a lot of very similar attributes that come from our HPC systems. Their bare metal deployments, the resiliency is built in the operating system. They're not running MPI, they're not running parallel environments, but a lot of the infrastructure that they're building have a lot of parallels in how they deploy and the types of hardware and density they want. In the future, we're doing things in advanced water cooling and areas like that as you start to look at these Web 2.0,
You're looking at technologies going the other way.
I'm looking at them going the other way, but I think they're advancing. I mean, if you look at the hyper growth that's occurring in these data centers and see the business models that they're taking on, they're going into financial services, or they're going to do risk analytics in the future. They're going to be doing a lot of data and information. If you look at what Google is after and what kind of data they're going to have to compile and act on in the future. So today, no. In the future, I think there's opportunities.
John Mark, you're a supercomputer company here. Are these supercomputers over there? Are we watching them for technology?
So I agree with Mike on the point that the classical HPC way of life is driven by grand challenge applications. So one application, one machine, simple, and one result. The fact is that the Yahoo and Google and so forth are supercomputing people to some extent. Today it's about the infrastructure.
To some extent, you get CTOs of supercomputing companies getting hired by Google. There's supercomputing talent over there, man.
Salaries are higher because this is an increasing market while HPC is a stagnating market. I would move to Google if they made me an offer.
All right, keep going, John Mark. I interrupted you. It's Google here. Did you bring your resume? You don't need one. Keep going, John Mark.
There are two aspects on the fact they are HPC companies to some extent. This is the situation today where there are supercomputing companies for the infrastructure question, about power consumption, about manageability of the system, deployment, maintenance, support, load balancing. All of that is the same issues as we are facing as supercomputer companies.
You get a lot of points for that answer because an area they're having a lot of influences in the open stack with things like cloud software. And that's coming hard toward anything that has to do with HPC in the cloud, which is why I saved you for last on this. I mean, you're talking about wanting to do cloud. You're on the commercial side. Is there anything they're going to do with that ultra-scale side that ultimately influences what you do in your shop?
I personally think that they are using big computer, whether it's supercomputer or not, depending on your definition, to do big data stuff rather than the conventional supercomputing stuff that Mike.
All right, you're shifting the definition, but the point remains, is there going to be technology there that influences HPC?
Not those that are directly relevant to the kind of simulation work that we use in the manufacturing and engineering sector.
John Mark, I cut you off before. I'll give you the last word.
They are going to influence the classical HPC world for one reason, cost reasons. HPC industry has been driven by cost forever. So mainstream technologies, low-cost technologies influence HPC world.
I'll tell you one other influence they're having is that as a build versus buy segment, they're increasingly bypassing traditional server ODMs like Bull and IBM or Lenovo and going directly to the component providers, which is having also a market effect in terms of how you bring these solutions to market. It's got an interesting channel solution. All right, thank you for your in-depth insights. We're going to speed up a little bit. Speed round here. More vendors are bringing liquid cooling-based solutions to the market, citing optimization and power and density. Is this what the end user community really wants, and what percent are going to adopt liquid cooling, Brian?
I can't give you a percent, but clearly it's growing significantly. I think without a doubt, if you're building a green data center, a new data center, you've got to look at liquid cooling and water cooling as it goes in, because the ROIs have come down quite a bit with a lot of the innovations and looking at the capital cost of building a new data center. I think in a brown data center, you got to do some evaluation. But I think there's an awful lot of other benefits when you get into the density, we get into the power savings and the energy savings. And there's a third area when we deal with a lot of countries when we ship into in India and China, where reliability is such a big factor. The air quality is not very good. So we deal with an awful lot of systems that just quite honestly have early reliability issues because of air quality.
Brian's all in on liquid. Jean-Marc, where's Bull going with liquid here?
So we are liquid cooled, I would say. All our systems now are with a direct liquid cooling solution. But I think your question was about the user advantage.
That's right.
For liquid cooling. So today there is no direct advantage for the user. Tomorrow, yes. Let me explain. It's all about cost once again. Today users don't pay per CPU per hour usage. Tomorrow they will pay per power consumption usage.
Okay.
So if the global PUE is reduced, they will pay less. End of story. So they will get better usage of the systems.
I kind of like what you just said. Today, this is not a direct end user advantage. We're investing in it for tomorrow. I did the vendors first on purpose. Yoon, what do you think in liquid cooling? Is this something you inherently want?
I think so. It will lower the total cost of ownership, and that means lower running costs. And what that means is it will free up some additional funding to buy more compute core that will directly benefit the end user. So I think there is a direct benefit the end user will get.
Michael, are you going to the vendors saying, bring me liquid cooling?
No, we are a small center, we don't do these things. We just take what it needs to solve our problems. Liquid cooling is there, systems are liquid cooled, we have to do it.
Do you care? Oh, well, you're saying I have to do it. They're making me
Right,
do it.
right. I don't care. I don't care. I look at a system. System has to be up and running, has to perform, and that's it.
Second speed question. What's your outlook for object storage in HPC? This is another topic we're hearing about a lot from the vendor community. In particular, is this going to go so far as to break us away from a file and directory-based approach, Jean-Marc?
Yes.
We're going to get rid of files and directories and go object storage operating
It's
system.
both. It's not an opposition between files and objects. It's complementary. HPC will have to deal more and more with the reality, with the real life, with the complex world, where any data is heterogeneous, totally unstructured. So object storage is a fact, and it's going to be more and more a fact, even
Brian,
in
you
traditional
agree?
HPC.
Not completely. I think file systems are embedded in a lot of applications, a lot of workflows today, so they're not going to go away anytime soon. So object clearly is on the rise, and it'll take on a life, and it'll probably accelerate, but it's been a long time to move file systems.
Michael, object storage.
This time I have to, the cameras are hopefully on and everybody's listening. I fully agree with Will.
Yoon, object storage.
I think the usage of object storage will increase. From our perspective, I think it's ideally suited for archiving, backup, that kind of storage.
You
But
think
not-
10 years from now you're not thinking file and
No,
directory?
I say it's not all of it.
Not all the way.
Not all of it.
Last speed question. In the spirit of the World Cup, I want to start picking winners in the following matches here. First match, which is going to bring more net new revenue to the HPC industry? Cloud computing or big data, Michael?
Big data, definitely big data.
Big data brings more. Yoon?
Cloud computing, because it opens up to HPC to a lot of small and medium-sized enterprise.
Jean-Marc, which brings more new revenue?
Big data, definitively. It's going to give new fields of exploration for HPC.
Brian?
Well, I hate agreeing with Bull here, but big data, for sure, is going to drive.
I want big data also. Michael, you're the
drive
outlier.
opportunity.
Which is more difficult or more expensive to manage as systems scale? Personnel or facilities, Yoon?
I think it's the facility. Imagine-
Facilities is harder and more expensive. Michael?
I think so.
Facility is more expensive, but people are harder.
Okay, Brian?
For sure, people. I think we're being forced to fit as much as we can into the current existing facility, and that infrastructure gets fixed for us. So people, scaling people, subject matter expertise.
I love to agree with Michael. Facilities are expensive and people are hard to manage.
On average, the people are more expensive, and I think they're harder too. Which continent, I love this one, I can't wait to hear what people say. Which continent is going to deliver more HPC innovation over the rest of the decade? Europe or Asia, Brian?
It's a flat world, Addison, and collaboration
You can't opt
is
out,
there.
man.
It is a flat world.
Where am I looking harder for innovation, Europe or Asia?
There are different parts of innovation occurring in Asia around Web 2.0.
You're skipping the question, Jean-Marc. That was lame, Brian.
Europe.
Europe.
Hardware
From
with,
Europe.
with ARM, with programming model, with European Commission programs like Horizon 2020.
Europe or Asia?
Trace.
Where's more innovation coming from?
I think it'll be from Asia simply because there'll be a lot of funding going into it.
Yeah, Michael.
I think we'll see most innovation if Europe and Asia are able to agree to merge their potential.
I think this is in transition. 5 years ago, I would have said Europe. This year, I'm going to say Asia for this one. I'm going to add one bonus question in the spirit of the World Cup. All right, so England doesn't matter. You're already out. France, you've already advanced. Germany, U.S., we got this tonight. Who's winning here?
I'm an Austrian and I really strongly hope that the US wins. And the reason is that my son, my 12-year-old son, is a US citizen.
Here we go. We'll line up for that. All right. Last traditional question. This is what we do every year. Last topic is one up, one down. You've experienced the full ISC 2014 show. What I like doing is tell me one thing you were impressed with this week, and then one thing that maybe could have been better this week. Brian?
Well, whatever, but I won't count that one. It's much better than last year. But clearly the conversations, the energy in the environment, all the client meetings we had, the sessions here, I think the high energy was very positive this year. Negative, I'd say it felt like attendance was down compared to last year. It felt like there was less people here than
I think there were a few vendors who opted out, which I think is a big mistake, and that drops attendance down, but that's another thing I could come back to another time. Jean-Marc?
So to me, there are two winners. First, this is the rise of data. Data is getting central. Second, the rise of usage model. We see more and more projects like Human Brain Project, where HPC is a component of a global project. Or in medicines, that's very important as well, where HPC is a small component of a global process in medicine. So if I have to choose one loser, I would say the other way around, this is the processing unit. It's been our key word, performance of the processing unit for years, for decades. So with data on the workflow, on usage model being central now and more in the future, the processing unit itself is going to be banalized and commoditized.
That's an interesting answer. That's cool. All right, you.
I think the keynote on Monday on biomedicine and bioengineering, to me, that's a high point because that's driving towards personal medicine that will benefit every human being in this world, and HPC play a part.
You could add the brain presentation we just had on
of
that.
course, yeah. I think that the low point is probably, not everybody will agree, but I think that the confirmation in some sense that IBM is bowing out, as Professor Thomas Sterling put it yesterday, a giant bowing out, and IBM is so much a part of.
Brian, was there a confirmation that IBM has bowed out of the HPC industry?
no, not that.
I was just checking.
It's x86 system.
No, IBM, as we leave, we will stay in it, in the x86.
Yeah, we already did that panel. We did that panel on Tuesday. Okay, Michael.
So you actually have
Last word's yours.
three questions, and I'll answer your last question first. Your last question was what is missing? And the one person I missed was Hans. Actually, over the last 4 days, I was always expecting him to come around and say, Michael, you're talking this, or Michael, you should do that. I really missed him. The ups and downs, I think the up is that we have seen so many different directions, so many options, technical options, so many new people, new faces.
Yeah.
I met a number of interesting people, so this is really an up. We are sort of getting more vibrant here. At the same time, it's a down because, as Mark said before that, we haven't yet decided of which directions we are going to take. We are in a very open space, and this is a disadvantage for us when we try to move to much larger systems than we have today.
Well, I'll do my winners and losers as part of our weekly podcast series This Week in HPC with my co-analyst Michael Feldman, distributed with our partners on Inside HPC. You can listen to that there. But for now, panelists, thank you. That concludes Analyst Crossfire, and with it, the 2014 ISC conference. Audience, please join me in again thanking my panelists, Brian Connors, Jean-Marc Yunho, and Michael Resch, for bravely sharing their insights, as well as the excellent ISC events team for another successful ISC conference. I look forward to seeing all of you next year in Frankfurt. Signing off from ISC'14, I'm Addison Snell with Intersect 360 Research. Thank you.